Now, what if I want to convert something from rectangular into the trig or polar form? We're going to go through a series of steps to follow to kind of make it a little more succinct. The first thing you want to do is sketch a graph of your complex number so that you can identify what quadrant you're actually talking about. Then you would find r, or the magnitude, and finally you would find theta. You need the r and theta so that you can plug it into this form right here. So you can look at it there. Now, because most of the errors occur in step 3, in other words, putting theta in the wrong quadrant, that's why we're going to go ahead and draw the picture first. So let's look at 2 examples together to do this. So in this first example right here, again, I am converting from the rectangular or complex number into a trig or polar form. And we are going to do that using this complex number, negative square root of 3 plus I. And we know to stop when we get it in this form right here. So since the first thing we're going to do is sketch our graph, let's go make our system. We have our real and imaginary, we'll call it that. We have our real and imaginary axis over here. I know that I'm going to be moving negative square roots of 3 along the real axis, so I'm going to move in the negative direction here, and I'm going to move positive in the imaginary direction. So I'm over here. Now, how far did I move in each? Well, I can represent this as negative square roots of 3 going in the x direction. So this would be negative square roots of 3 in the x direction. And then I moved one direction in the y, or the imaginary. So I have a 1 here. And ultimately what I'm being asked to do is find r, okay, which would be the hypotenuse of my triangle, as well as theta. I need those 2 components in order to write this in its polar or trig form. So now that we have our sketch drawn, we know that we're over here in quadrant 2. Let's go find r. So since r is the hypotenuse of this triangle, it's the square root of the x value, or the real value, squared. So negative square root of 3 squared plus the imaginary component, or 1 squared. Therefore, we simplify this. This will be 3 plus 1, which would be 4, and the square root of 4 is just 2. So there's the r portion. Next, we need to find out what theta is. Remember, theta comes from the inverse tangent of y over x. So in other words, for what angle, when I take the tangent of it, do I get 1 over negative square roots of 3? Well, we have to be over here in this quadrant, and hopefully you know that that's going to be 5 pi over 6 is going to give me that angle. So once I have r and theta, it just is simply writing it as 2 is r, and then we give the abbreviation CIS, and then theta, which is 5 pi over 6. And that's the solution right there. It's very straightforward, and we go ahead and use the abbreviation here for CIS. Now let's practice that one more time. By the way, if you didn't notice, we were using radian measure here. In other words, that's how come I gave theta back in radian values, because in this example, we're going to use degree measurements. So the first thing we want to do, though, is draw the graph. So let's sketch our graph. We have negative 15. Now remember, before I sketch that, remember that all numbers can be written in their complex form, and they would just look like negative 15 for the real portion plus 0 I for the imaginary portion. So this is the complex number that I'm going to now sketch over here on this graph. I am moving negative 15 along the real or x-axis, so I'm moving in this direction, and I am moving 0 up or down in the imaginary direction. So here I am over on the graph over here at negative 15. Now, if r is the distance from the origin straight out to my point, I could kind of figure that out in my head already. That's r, and then I know theta is the is the rotation from the starting point over to where we've stopped here. So now that I have that, let's figure out, we want to find R. And because we've drawn our picture, you can see it's kind of straightforward. R is just 15. Now why do you suppose R is 15 and not negative 15? Hopefully you see that because R is going to be the distance or the magnitude, we are moving from the origin straight out to this point a distance of 15. So it's just positive. Now for theta, so that's the third piece of this puzzle we have to find, is theta. So finding theta. Remember, theta is for what angle, when I take the tangent of it, do I get over here, what angle is this over here when I have moved? So I have y over x, in other words, to finish that off. And we can kind of see just from the picture that we've drawn that if I move over here to where R is and stop, I have moved 180 degrees because we're writing this in degree measure. To finish this off, to write this in its CIS theta form, or in other words, write it in its polar form, this would look like 15 CIS 180 degrees. And that's the solution to that. And that's how we're going to go from a rectangular or complex form into a triangle, polar or form, or trigonometric form.